Hi there. This is day 3 of my 30-day journey on fraction, where I attempt to solve all fraction related problems that are primarily and specially picked from past common entrance examination, GSSE, SSCE, and even SAT, which is Standard Aptitude Test. Now, as usual, before I proceed on this video, please make sure to click the subscription button below this video to get notified of more academic and educative videos like this. Now let's look at the first questions for today's episode. The question says, if a seamstress needs model number 3/4 meter of cloth to make a blouse, how many meters will be needed for 6 blouses? And let me read that question again so that you can think. If a seamstress needs model number 3/4 meter of cloth to make a blouse. So I'm going to underline that word, a blouse. How many meters will be needed for 6 blouses? Now, this is easy to interpret. How do you go about it? If a seamstress needs model number 3/4 meters of cloth to make a blouse, that interprets to be that for every one blouse that will be made by the seamstress, she's going to need one whole number 3/4 meter. Now we've interpreted this into a mathematical equation. So for every one blouse that will be made by the seamstress, she's going to need one whole number 3/4 meters of cloth. Then the main question then says, how many meters will be needed for 6 blouses? That means for every 6 blouses, how many meters will she need? We don't know. But how do we solve that? How do we solve this puzzle? If for one blouse she needs one whole number 3/4 meter, definitely to make 2 blouses, that means this is going to repeat in 2 times. To make 3 blouses, this is going to repeat in 3 times. To make 4 blouses, this is going to repeat in 4 times. To make 5 blouses, this is going to repeat in 5 times. And to make 6 blouses, this is going to repeat in what? 6 times. So definitely, for every one blouse that will be made with one whole number 3/4 meter, then for 6 blouses, we are going to need 6. We are going to make 6 times one whole number 3/4. So we are going to rationalize this 6 to operate on this fraction now. 6 times one whole number 3/4 to find out the numbers of meters of cloth that will be needed to make 6 blouses. So we rationalize this 6 and make it a fraction by making it 6/1. We rationalize it as a fraction, then we still repeat the times, and then this will be converted into an improper fractions because we don't operate on a fraction, whether division or times. We don't operate on a mixed fraction in its pure form. So we convert this into an improper fraction. So 1 times 4 will give us 4. 4 plus 3, that will give you 7. That's how you convert a mixed number into improper fraction. We multiply the whole number by the denominator, then add it to the numerator. So 1 times 4 will give you 4. 4 plus 3, that will give you 7/4. Now that we've successfully converted this into this, now let's operate on these fractions now. So to do this, to simplify this, we look for what can divide across like this or like this. Don't forget, in my recent lessons, in my previous lessons, I've explained to you that if you're going to divide or multiply a fractions, what you do is that you only divide a numerator by a denominator across, a numerator by a denominator across, or a numerator by a denominator also across like this. You don't ever divide a numerator by a numerator, neither do you divide a denominator by a denominator. So let's look for what can divide across, because we could see that 6 and 4 are even numbers, so that means they have a common factor. So their common factor is 2. Common factor means a number that can divide both numbers. So 2 can divide 4, 2 can likewise divide 6. So 2 in 4 will give us 2, 2 in 6 will give us 3. Then 7 and 1, nothing can divide both of them because they don't have a common factor. So what do? We multiply the rest of the number that we have by checking out the numerator. So in the numerator, we have 3 times 7, and that gives us 21 over. Then in the denominator, we have 1 times 2, and that gives us 2. So we have 21 over 2, which you can see, or which you know, or which you should know, that 21 over 2 is an improper fraction. So we have to convert it back to a mixed number. So how do we do that? We simply say how many 2 can we count in 21, or how many 2 is there in 21? We are going to have 10 because 10 times 2 will give you 20, leaving a remainder of 1 then over this 2. So 2 and 21 is 10, remainder 1 over 2. So we are going to need 10.5 meters of cloth to make 6 blouses. So let's move on to the next question. Now, let's proceed to question number 2 of today's episode. The question says, how many times does a cup 3/10 liters hold a container of 15 liters? Let's repeat that question. How many times does a cup 3/10 liters hold a container of 15 liters? Now, there's a key word for us to note here, which I have also explained in my previous lessons. How many times? Whenever you hear how many times, that's simply interpret division, because this simply can be interpreted as how many times can you count this in this. That is, how many of this cup can you take out from these liters? So we go straight to the point by saying, by interpreting simply as how many three over 10 is in 15 liters. Now, this interpretation is not mathematical, so we still have to express it as a mathematical term. But then you should understand it simpler this way, easier this way. How many 3/10 is in 15 liters? That means how many of this is in this? So mathematically, that will mean that 15 divided by 3/10, because that's what how many simply means. It's just like saying how many 2 is in 6, how many 2 is in 5. So how many of this is in this? So that is 15 divided by 3/10. Now, like I did in the previous video, we first of all have to do some things here. We rationalize this 15 by turning it into fractions, so it will become 15/1, and then this divide we change to times. Now, this divide turning to times, we condition this fraction here to invert. Invert means the denominator will become the numerator, while the numerator will become the denominator. So we are going to have 10/3. Now that we've expanded, or we've simplified this part of the fractions into this, or we've transformed this part of the fraction into this, and let's go on operating on it. So to operate on it with these times, we first of all look across what can divide. 3 and 15 has a common factor. That means they have a number that can divide both of them. So the common factor of 15 and 3 is 3 itself. So 3 in 3 will give us 1. 3 in 15 will give us 5. And let's look at 10 and 1. Nothing can divide 10 and 1. So we just simply multiply the rest of the number, which is 5 times 10 in the numerator, and that gives us 50 over, and then 1 times 1 in the denominator, and that gives us what? 1. Now 50 divided by 1, like I have told you before, any number divided by 1 gives you the same number. So 50 divided by 1 will be what? 50. So going back to the question which says that how many times does this can hold in this? So it can be held in 50 times. 50 times. So that is that about question 2. So let's move on to question number. Now, for question number 3, it says a rope 10.5 meters long is cut into equal pieces of 3/4 meters long. A rope 10.5 meters long is cut into equal pieces of 3/4 meters long. Now, whenever we hear cut in mathematics or in word problems, it could either translate as subtraction or division. But how do we see, or how do we draw the discrepancy between when it is used as subtraction or division? We just simply look at the main question. The main question says how many pieces, and don't forget, I don't need to give you the judgment for this. How many? We've already done that in the previous example. How many connotes division. So how many pieces are there? That means after breaking down this 10 meters long rope, how many pieces can we get when we break down this 10 meters long rope into equal pieces of this? So we interpret that as, we give that a judgment of division, that is how many, a simple description or a simple interpretation as how many 3/4 is in 10 whole number 1/2, which you can assume, or which you can presume to get a better understanding, as saying how many 2 is in 10, just for you to understand. So how many 3/4 is in 10/2? So mathematically, that's get a judgment of division. So how many this is in this? That means if you break down this, if you divide this by this, what do we get? So 10 whole number 1/2 divided by 3/4. And of course, as you've learned in the previous example, 10 whole number will be converted into an improper fraction. So 10 times 2 will give you 20. 20 plus 1 will give you 21/2. And then this division sign we change to times. Don't forget that. We don't divide division, or we don't work on divisions of fractions in a straightforward manner or as it is. So we first of all convert the division into what? Multiplication. So the division we turn to times. So the division turning to times, we condition the number in front to invert. Invert means the denominator becomes numerator, numerator becomes the denominator. So 3/4 becomes 4/3. Now we can operate on this fraction. So how do we operate on it? We check what can divide across, that is across the numerator and denominator. 2 and 4 has a common factor, which is 2 itself. So 2 in 2 gives us 1, 2 in 4 gives us 2. 3 and 21 has a common factor as well, which is 3 itself. So 3 in 3 gives us 1, 3 in 21 gives us what? 7. Now nothing else can divide, or nothing else can be simplified, so we go on multiplying what we have left. So to multiply, we do numerator and numerator, denominator and denominator. So 7 times 2, that gives us what? 14. And then 1 times 1, that gives us 1. Don't forget that any number divided by 1 gives you the same number. So 14 divided by 1 is 14. So if this row is cut into equal pieces of this, we are going to get 14 pieces. We're going to get 14 pieces of this. So that is that about question number 3. Stay tuned for question number 4. Now, question number 4. A drum has 13 number 2/3 liters of water in it. More water is poured into it to make it 15 whole number 1/4 liters. Now, main question, how much water was added? Let's read the question again. A drum has 13 whole number 2/3 liters of water in it. So that is the initial liters of water, because whenever you see this word more, that means you're talking about something that has an initial stage and then it became into something else because there is now more to it. So we interpret that simply as initial liters. I'm sure this question is familiar. We've solved this kind of question before. Initial liter is 13 whole number 2/3 liters. Then the next part of the sentence is more water is poured. The more water. So more water will be interpreted as additional liter. Additional liter. Now, unlike the question that we solved before, we weren't given the additional liters in this regard. More water is poured, but they didn't give us that more water that was poured. So I'm going to put a question mark to show that what is more water that was poured. And then proceeding into the sentence says into it. That means more water was poured into the initial liter to make it. To make it means the new liter. To make it. So making it will be new liter. New liter to make it 15 whole number 1/4 liters. So the new liter is 15 whole number 1/4 liters. Now, what does the main question say? The main question says how much how much water was added. That means what is the additional liter that was added to make it this new liter. Now, if you look at the slope of the question, this is the initial stage of the water, and then something was added to make it this. That means this plus this gives you this. So, applying your logic and your common sense, you just simply reverse the situation. Since this plus this gives you this, which is the new liter, to get what is there, we just simply say this, take away this, and then it will give us what? This. Or this, take away this, it will give us what? This. So we just use reversal method to find out the answer. By the way, your common sense and logic should also work for you here. So this is the initial liter, and then this was added, and then we now have a new liter. So to find what was added, simply take away the initial liter from the new liter. So, and that is what we are now going to do. So I'm going to make a sign here, which is therefore additional liter equals to 15 whole number 1/4 minus 13 whole number 2/3. This is what we are going to do to get the additional liter. So don't forget, you always focus on the whole number in subtraction cases, in subtraction and addition cases. So 15 take away 13, we are going to have 2 whole number. Then we now work on this fractional part that is left, which is 1/4 and 2/3. First of all, we draw a line for their common denominator. So we find the common denominator of 3 and 4. So the common denominator of 3 and 4 is 12. By the way, common denominator also means LCM. So LCM of 4 and 3 is 12. Then when you've done that, you use each denominator to divide the common denominator. Whatever result you get, you multiply it with your numerator, as we've been learning from the previous lesson. So 4 in 12, that is 3. 3 times 1, that gives us what? 3. Then their relationship is what? Minus. I'm going to put the minus. So 3 in 12, that is 4. 4 times 2, and that gives us what? 8. Now, we now have a new set of fractions, which is 2 whole number 3 minus 8/12. In this situation, to simplify these fractions, we can subtract 8 from 3. That is impossible. We are going to get a negative answer. But since we have an whole number here to borrow from, so we are going to borrow 1 from 2. So we are going to have a new whole number, which is 1 whole number. And don't forget, whenever we borrow 1 from an whole number, the whole number will be equivalent to the denominator. So the one that we borrow will become 12, and then it will be added to this 3, and then minus 8. Everything all over 12. So 12 plus 3, that gives us what? 15. 15 take away 8, and that will give us what? 7. So the additional liter is 1 whole number, 12 plus 3 again, 15. 15 take away 8, that is 7. 1 whole number, 7/12 liter. Additional was added. So that is that about fourth question. And this is where we are going to stop for today. Don't forget to please kindly and generously click on the subscription button below this video to get notified whenever I release more educative and academic videos like this. See you in the next episode.